a new way to do implicit differentiation. All right, so let's say I've got 3x e to the y minus 7x squared y cubed plus 4x minus 2 equals 0. Obviously, that's going to be needed to be to find dy over dx. We're going to need to do the implicit differentiation. However, here's what we can do. Let's consider the function I have on the left here as my two-variable function of z. Function of x and y, z equals f of x, y. So I've got an f of x, y equals 0. Okay? Trying to find dy over dx. Keep that in mind. That's what I'm trying to find. Dy over dx. Okay? Well, introducing this z, the two-variable function here. Of course, I've got z equals 0, right? Which that would mean the partial, or dz over dx is 0. That'll be helpful here in just a second. Okay? Yeah, because my function is 0, so the derivative with respect to x, of course, would be 0. Two ways around it. All right. Now, let's think dz over dx. We just went through that. All right, so I've got this function, z equals f of x, y. How do I get dz over dx? Well, I do the partial of z with respect to x times, all right, so now I need to do and here we're considering we're trying to find dy over dx, and so x is x, okay? The y is a function of x. We just don't know how to get that. So with that in mind. So I've got two variables, so I've got to do the partial z with respect to x, and then I've got to do the partial z with respect to y. Another way to look at it, I forgot I did the tree diagram here. So I've got z is a function of x and y, but then y is a function of x. Okay? So I guess really I could just put this as dz over dx plus then the partial. Anyway, let's leave it that way. Okay. Then I need to do the dy over dx. Well, yeah, so dz we've already discussed. Since z equals 0, dz over dx would be 0. The partial of this is just 1. So that's the partial of z with respect to x. And then this is the partial of z with respect to y times dy over dx. Well, this is what I'm trying to solve for, okay? Dy over dx. So if I solve that for dy over dx, here's what I get. Subtract the partial of z, partial of x, and then divide off the partial of z with respect to y. New way to get dy over dx right there. Or another way you can write it is our function negative function the partial of f with respect to x, and the negative of that divided by the partial of f with respect to y. Maybe an easier way to remember it. Because remember, when we did our ddx of both sides, we had to, do the product rule, and that would involve a lot of product rules and dy over dx. But here, this cuts right to the chase. Okay, you just do the partial of this thing with respect to x, and then do the negative of it, and then divide it by the partial of f with respect to y. So, what is dy over dx based on that now newfound knowledge? So dy over dx would be this this thing right here, partial of f negative this. What's the partial of f with respect to x of that? So fixing the y, the x is the variable here, so that would just be 3 e to the y. Then the partial of this with respect to x would just be minus 14x y cubed. Partial of that with respect to x is 4. Plus 4, and that's 0. So that's our partial of f with respect to x. Bottom is partial of f with respect to y. So now do this with respect to y. What's the partial of that with respect to y? Y is, x is fixed, y is the variable. So it'd just be 3x e to the y. Then with y, so it'd be minus 21 x squared y squared. You got the power, subtract 1. And then since we're doing it with respect to y, those are both 0. There you go. Nothing really to clean up. Could distribute the minus, but the dot. Pretty nice. Now, this one. So, there is a this to use this method, it does have you do have to have the function of x and y equal to 0. dy over dx is negative. So that is a key component of it, is that you have a function equals 0, or a function of two variables equal to 0. So if I've got y squared minus x squared equals sine xy, well, I can't yet apply this to find dy over dx, because I don't have one side 0, but of course that's easy enough to fix. Make right side be 0, subtract the sine xy over. All right, and so that's going to define my two variable function. And so dy over dx, that's all I'm interested in. Negative partial of f with respect to y, or negative over partial of f with respect to negative partial of f with respect to x over partial of f with respect to y. So it's negative 2x minus cosine xy times y, because that'd be the partial of f with respect to x, and then the partial of f with respect to y, 2y, derivative of that 0, minus cosine xy again, Derivative of the outside, derivative of the inside is x. With respect to y. So it's 2x minus or plus cosine xy divided by 2y minus x cosine xy. One last thing, that is, it can be extended to 3 variables. It's just that in 3 variables, all right, so let's say we've got x cubed plus z squared plus y e to the xz plus z cosine xy, 0. Well, we did these a few days ago. And what we were looking for was what's the partial of z with respect to x and partial of z with respect to y. Those were the 2 things I was looking for there. In other words, I can't exactly get z in terms of x and y as a function, but I still want to know these partials. Well, I can extend this method to do this. The partial of z with respect to x here is going to be this. All right, so we've got it equals 0. So this is going to be f of x, y, z. And I've got that equals 0. And so I'm going to do the very same thing with it. Partial of z with respect to x is going to be, well, it's going to be minus the partial very same thing. If I want the partial of z with respect to x, I'm just going to do this thing, do the partial of f with respect to x, and do the partial of f with respect to z, then for the denominator, and then the partial of y with respect to z. Partial of z with respect to y, negative f with respect to y, f with respect to z. Which would be very simple. Go ahead and do it. So it would be 3 negative of 3x squared over z. So x is the fixed one. Negative 3x squared plus, so z and y are fixed. X is the one that's the variable, so this would be plus y e to the xz times then x plus then all that's 0. And then the partial of f with respect to z, so that's 0, 2z plus y e to the xz times x. Oops, this should be z. This is x. And then that's cosine y is constant, so it's just cosine y. Anyway,